and good morning. Welcome to today's webinar. This is Robin Burrow, President for Omicron Systems, and I'm very excited to bring the session to you and also introduce you to our big data scientist, Shrikesh. We're just going to go with Shrikesh, but you can see Shrikesh in the camera there. Say hello, Shrikesh.
Hello.
Hello. And I want to point out some really fancy artwork for those that are familiar or are new to Omicron. Behind Shrikesh is a really great drawing that I drew myself. And there's a picture of Shrikesh, the upper right-hand corner. He has black hair, and there's me, looks just like me with my red hair. So that's Shrikesh and Robin. And to kind of give you a familiarity with why we're doing this session, Shrikesh is a big data scientist from many years back, and he was in our office recently, and I said this open question, Shrikesh, tell me about big data. It's so confusing. There's so much to it. You know, please explain it to me in layman's terms. And so what you see here is what was our whiteboard. And as we got into it and he was explaining it from piece to piece, tool, about the event data, you know, the problems that people are trying to solve, the technologies, we just felt like, wow, we really should do this webinar because I know a lot of people have as many questions as I did. And this is also a really nice introduction into some of the Omicron big data services. So with that, I'm going to move on over to my slide, and I will start the slide. I'll stop annotating so that I can go back and annotate. Okay. And here we are. And how are we doing there? Okay, Basu, if you have no audio, you might want to call in. Sorry, I didn't do that privately, but if you're having problems hearing, then go ahead and call in with the information that was provided. Okay, can everybody see my screen okay? You should see the big data analytics, and I'll just move this guy off. Can you guys see my screen okay?
Yes.
Okay, thank you. Great. So I was going to just take a poll, but I've already used up our time. So I'm going to go ahead and click through this piece of it. And of course, there we go. Okay, good. And then we had another poll question, and I'm going to just go ahead and pass through that. I do want to tell you that we're going to do a raffle today. So Omicron, as a training company, really likes participation. We're doing this as a webinar, but it's not just Shrikesh talking. It's not, you know, you learn as much from thinking and asking questions and hearing from other participants as you will from Shrikesh. So when we get a lot of participation, you'll be entered into a raffle, and we'll be giving away a favorite book from our CEO, Basu, called Big Data. This is an excellent book. So I wanted to let you know there is an opportunity and rewards for excellent participation. Today's topic is big data analytics. We're going to talk about key terms, concepts, and where to begin. And Shrikesh has been with big data before we called it big data, and he's the perfect expert to kind of give you a little bit of an overview of some of the do's and don'ts so that you can not waste time and not waste resources and just learn from an expert. That is Shrikesh, our big data expert and also Omicron, one of Omicron's big data scientists. He was the former director of business intelligence at MGO and also the head of data management at Zenith. And before that, he was the director of data science and business intelligence at Shopzilla. Does anybody remember Shopzilla? You can chat to me if you remember. That was kind of a fun store, and actually online store back in the beginning. Shrikesh set up the first Hadoop instance before Hadoop was even popular. And that's me, and I'm the president of Omicron. And my primary focus, just so you know, is to help companies build leaders on demand and also help individuals become leaders in demand. That's what we're all about. So, Shrikesh, I'm going to let you start with the agenda. How's that?
All right. Good morning, everybody. I'm really excited to be here to do this talk about big data analytics and share my passion about the topic. Like Robin said, I have several years of experience working in data warehousing and BI systems, and then over the last 3 to 4 years, I've been really focused on analytics. And prior to that, when I was at Shopzilla about 8 years ago, I did the first Hadoop implementation where I transferred about 30 terabytes of data warehouse from an Oracle instance that was very highly performing into a 15-node Hadoop cluster, and that's where the journey for me began. And I'm really fascinated about this whole area and how it's really helping businesses change. So as we said many times, the big data analytics is a huge topic, and when we initially discussed about okay, let's do the webinar, one of the questions was, okay, where do we start? And then so the Mr. Basu and Robin, they suggested that since this is the first time we're doing this, we will start with the basics, and we'll try to introduce the topic to you. We will cover the key terms and concepts around big data, and then go into some of the deeper topics and different areas within the big data analytics, and then talk about some of the tools and technologies, and then from there we'll discuss some of the current trends, and then close it with some Q&A. So that's sort of the agenda for today, and let's start with the big data analytics. What is big data analytics, right? So I want to start out with sharing a story. Back in 2007-2009 timeframe, the H1N1 virus, also called the swine flu, was making a lot of people sick, and the CDC and other medical professionals were trying to get a grip on predicting where and which locations the next outbreak would occur, and the government professionals and the medical professionals, they were using clinical data and physicians' report, and coming up with weekly charts that would indicate where the or tell where the outbreak has been in the past months, and where the potential areas are. And along comes Google, a tech company, and some researchers at Google, they attempt to solve the same problem using a completely different approach. And what they did was they used the search terms related to the flu, and how people were searching for different terms around that, and then they used the search terms and the location and other information to predict the outbreak at much faster pace, and almost within hours. And it was a completely different approach that the company took, and it was accurate for the first few years, and later on there were some problems with it. But that shows the amount of value, or it's a classic example of how big data was used to solve real world problems. And another example that I would like to share with you is the Human Genome Project. Most of you know about the DNA project. It started in the 1990s, and it was probably one of the largest projects where in the medical area where a lot of information was shared between across different countries, and there was huge pile of research that was done in collaboration with the idea to map the human genes. And a typical human genes, there are about 20,500 base genes, and then these genes have about or millions of associated base chemical pairs. And the sequencing project was to actually map out all the millions of base pairs across these 20,000 odd genes, and the problem was the first time the mapping was completed was about 2003, and today where we are with that. That project closed, and today what is happening in that area is that medical companies, pharmaceutical companies, as well as medical professionals are trying to understand the interaction of the various genes along with the human behavior, that our day-to-day behavior, as well as how the medicines affect these base genes. Now, to get a sense of the size of the data we're talking about, a typical the complete mapping of a human gene takes tens and tens of gigabytes of data, and when they are doing this analysis where they are looking at interactions between various genomes, it's petabytes of data. And that's a point that I wanted to highlight with these two examples, which is that in both of these examples, it's a classic example of how large volumes of data are used, and some patterns and trends are revealed out of it to great use, and that's kind of the definition of big data analytics. It refers to large sets of data, and these data can be structured or unstructured, and I'll go into the definitions of what all this means. And they are processed in real time, or they are processed in a traditional batch mode, and then it can be further analyzed using advanced techniques, and I'll also talk about those things to reveal patterns, trends, and associations. And typically, big data is in a technical sense. The technical world is defined in terms of the volume, the velocity, the variety, and the veracity. What that means is, the volume, as you know, is just the size of data that's created. Most of the institutions today grapple with the challenge of to storing vast amounts of data and making use of it. So that's what the volume part of it is. The velocity part is where there are real cases where data is streaming in at very fast pace, and real-time decisions need to be made. So, for example, there are sensors in cars today, that's collecting data, and it has to make almost real-time decisions in terms of what to do next. So that's a classic example of velocity. Variety is what I was saying earlier. I touched upon earlier in terms of the structured and unstructured data. We just have so many different types of data in the world today. There's multimedia data. There's just Word document, and all of these data is used to or analyzed to make some sense out of it. And one of the last terms, the veracity, which was added recently, it was not there in the original previous definition. It actually talks about the quality of data that's collected, and a lot of times you have some parts of the data missing, or some things don't send the data the way it was supposed to, and there are ways to tackle that, and that's the veracity term. On to the next slide.
Thank you. So it's no longer 3 V's, it's 4 V's now, right?
Yeah, they're also talking about, they're also talking about 5th V now, but, I think these are the 4 ones that really matter.
Okay. What's the 5th V? Now you got my curiosity. Do you remember?
It's actually related to the quality. It's actually related to veracity. I just trying to remember exactly what the term was, but I think it's an offshoot of veracity.
Okay. Okay. Cool. Thank you for that. Yeah, I know it was 3, then 4, maybe 5. Okay. On to structured and unstructured data. Are you with me, Shrikesh?
Yeah, I cannot see the slide. Okay, there you go. Good. All right, structured and unstructured data. So structured data, by definition, it says that the data has some sort of structure, and that's the data we used to historically, where data is stored in some sort of rows and columns. There are relationships between the data, and the data is stored along with the relationship. So structured data is something that we all used to relational data, and unstructured data is the data that has come up in the last, but it's been there before, but it's used more widely today. It's all the data that we mostly consume today in videos, images, email, Word documents, and satellite images, scientific data. In business world, most of the unstructured data would be, like I said, the text documents, the PDFs, the emails, and all that. And these are the fastest growing data areas, right? We're consuming a lot of these unstructured data today. And there is also another category, which is the third category, which is the semi-structured data, where the structure is loosely defined along with the data, and some of the examples of that is XML, CSV, JSON, and some of the NoSQL databases, and I'll talk about what NoSQL means later on. They're all sort of based on the semi-structured data. The next slide.
Okay.
All right. So great. So now we are going to talk about some of the key terms and terminology. And before talking about that, I want to talk about some of the history around these terms and terminology. It all started back in, I would say, around 2003 to 2004, where all these large internet companies, large internet companies, they had a very symbiotic relationship between them, where so the companies like Google, Yahoo, Facebook, Twitter, LinkedIn, etc., were very heavy users of data and as well as creators of data, and they have to find new ways of storing and processing data, because they're just dealing with so much large volumes of data, and the traditional technologies back in the time, the relational databases and all that, they were just so expensive for them to use. So what they did was they hired some of the best engineers, and then they built their own infrastructure all the way from the networking and the data storage and the processing of it, and that whole infrastructure is what we know today as the big data. So it all started back in the days with these big companies. And what also happened during that time was there was this open source concept of sharing of technology, sharing of code across the industry, and that was accelerating. And what these companies did was they actually made the software they were using. The key concepts behind behind the software were made public and available to people. And for example, Google came out with the big table white paper, and that led to the people from Yahoo, and other people in the industry to build the Hadoop system. Facebook built the Hive database platform, which sits on Hadoop, and it's widely used as the single most sort of relational structure within the Hadoop system. And all these companies, they have, LinkedIn came up with the Kafka platform. So all these companies have collaborated and provided a lot of influence in this area. Now let's talk about the scale. As I was talking about some of the examples, in large volumes of data, as you can see through this slide today, we create about quintillion, which is like 2 raised to the power 30 or something of databytes. There are about 18.9 billion network connections in the world today. That's about 2 to 3 network connections per person in the world. There are about 4 billion hours of YouTube watched each month. That's many, many years of time. So, I mean, you can see the volume of data that we are talking about. Twitter, for example, 500 million tweets a day. And with all this large volume of data that is created, that is consumed, and what is happening is businesses are using this data to make more sense of what is going on around with the people, with their customers, with the people they are interacting with, and the most beautiful part of all this is we are still only, of all the data that is created, we're still only scratching like the 1% of data that is used for analysis purposes. So there is a lot of data that is just not even touched upon and used, across all the industries. That is going to be, I believe, it's going to be used more and more, and there's going to be a lot of emphasis and focus on the analytics part of it.
Yeah, but Shrikesh, I heard that 18.9 billion, that's going to switch over to about 50 billion network connections. Even by the year 2020, it's mind-boggling. So that, in a nutshell, that's the biggest reason for big data is there's just so much coming at us now because of the tools that we're able to access, that's why we're here now with big data, because we've figured out how to get that much information coming our way. Talk to us about how different industries are using big data, Shrikesh.
Great. So, and this is what, as the question says, what is so exciting about big data analytics? And every industry you can think about, they are using big data analytics in some way, form. I'll talk about the financial industry. I'll talk about the healthcare industry. My experiences with the retail as well as the media and entertainment. Great ways of using data to make better recommendations for users, to target users in different ways, so we can personalize the content for users. And then one of the things that people say is that back 8 years ago when President Obama got elected, his team used a lot of big data analytics research, and it was far better than Mitt Romney's big data team. So that shows this stuff is really it's important, and it can be used in many ways.
Watch me make Shrikesh smile, everybody. So are you saying we can use big data to make America great again?
Absolutely. I don't know how much.
All right, excellent. All right, let's talk about some of these industries.
All right. Okay, let's start with financial industry, and I'd like to start with financial industries because it's one of the industries where there is so much regulation in terms of the data used. Everything is audited. Things have to be done right, and the amount of security and all those considerations that need to be that goes into building the systems in a financial sector is far more than I guess the other sectors. So and financial industry is using big data in a big way, and here are the areas where they're using it. They're using for fraud detection. There's about within the different areas within the financial industry, banking, credit cards, investment management, and all that. There's a lot of fraud, and billions of dollars are lost just within credit card accounts for about 40% of the fraud that happens within this financial industry. So it's a huge problem, and they're using big data to solve it and to identify the fraud at a very early stage and detecting it, and they're getting better at it. So, for example, as most of us are familiar with credit card companies using location, and as we travel to different places, they sometimes they block the credit cards, right? So, and that can be annoying. So what they're doing now is that they're mixing the location data along with some of the social media data, so that they can understand, okay, this customer is actually intending to be in this place. It's kind of creepy, but but that's sort of the evolution of how big data is being used in that area. One of the other areas that they talk about is they call it the customer 360, which is basically trying to get a full picture of the customer and the marketplace, and basically how they can do segmented targeting to different customers, and then also improve customer satisfaction.
And it's kind of creepy, what you said before. That's
yeah. Yeah, I mean, it's the idea is to get consent from the users, and then use that sort of information. Customer analytics and marketing segmentation. This is another great area, and I have a lot of experience in this area. Where at MGO we were trying to personalize the content for users. We were trying to send personalized emails to people, to our users, and so that they can buy specific movies from us. And what has happened around this area is the main focus has been, earlier on, marketing was, you would run some ads, and the correlation with the ad and how the customers are interacting with the website or the business was not made to the extent it should have been. Data was not the driving factor for making decisions, and that's changing a lot. Where with the collection of data at different points, from the ad serving platforms to the website logs and all that, and you can sort of interconnect all the pieces and actually understand what ads are working and what ads are not working, what kind of promotions we can send out. I have an example of a promotion here where this was the email I got from PayPal, the little image on the bottom, where I had 4 different promotions that were sent to me. 2 of them are companies that I use, using PayPal, and the other 2 are just their big data prediction system that says, okay, this is going to be applicable to this person. So that's an example of how targeted emails are being sent out.
Interesting.
Healthcare, this is a great area of. They've been, healthcare has always been using large volumes of data. Pharmaceutical companies to do analysis to find new drugs and drug interactions and all that. And lately there is a lot of focus on preventative care and predicting issues on an individual basis, and that requires a lot of data collected on an individual basis, and associating that with all the different patient records and all the different treatments that we go through. So that's under big huge big data use case, and it's growing a lot. One of the things that we talk about is the power of precision care, and the idea behind that is that just where we can actually pinpoint precisely problems and make it applicable to people on an individual basis. And the last example I have here is the human genomics, which I talked about at the beginning. It's really fascinating.
What about this
All
one?
right.
I see. I think
Which one?
Just take a minute. And product recommendations.
All right, product recommendation. This is another example of use of big data. Most of us are used to shopping on Amazon, and it's a company that really uses product recommendations to persuade us to buy more products and recommend us products that we really like. And there was a research that was done that would say that over 2/3 of the consumers said that they would positively interact with the brand in response to a positive personalized experience. So personalization and product recommendations are really important in the online world today. And Netflix is an example where they use a lot of hard analytics to recommend the right movies for you to watch.
That's really true. That's a whole. I buy so much more because of these recommendations. Yeah. I actually look forward to the recommendations. So, hey guys, I want to give Shrikesh a little bit of a breather. We still have time on this. Insurance companies, lawyers, I like it. Those are good. Thank you. Thank you, S. Martin. I'm going to stop sharing my screen for a second and adjust something. I'm going to turn my camera back on, and then what I want to give us an opportunity for, now you guys can unmute yourself. Does anybody have any questions or any other, not questions per se, but are you guys using big data in your environment, or do you see an opportunity to use big data in your environment? You can chat that to me. I can see all of your chats now. So we had from Steve Martin or S. Martin the comment about big data being used in insurance companies, lawyers, target marketing, and it reminds you of security in Israel. Do you want to come off mute and talk to us about this for a minute? S. Martin, Shirley Martin? We use big data daily. We do use it. If you want to come off mute, you just go over to your name, right-click, and unmute, and that would be great. I see all kinds of chats here. Thank you, Claudia. The fifth V is value. And thank you. Yes, we do use big data daily, and it's happening more and more. Sort of a ethical question for you, and then I'm going to turn it back to Shrikesh. If we're going to get so good at predicting crime, throw this out to you, that we can predict, okay, there's going to happen, there's a crime, we predicted it, it's going to happen at 5 o'clock on the corner of, ABC Street and Y Street. And since I can predict the crime, does that mean I should go and get you before you do the crime? Like, really, we're going to be entering into those types of questions. It's a little bit weird, but thought I'd prepare you for that. Okay, Shrikesh, I'm going to turn this back to you. I just wanted to check people's chats without having our screen go wonky. So share and my screen and back to the presentation. And okay, we're on to tools, technology, and components.
Are we doing good on time, Ravin, or should I?
We're kind of running out of time, so let's go through this pretty quick.
Okay. So talk about the tools and technology, and I mentioned the 4 layers here. The 4 layers. This is not something that is set in stone. It's sort of my experiences in the area of big data analytics. These are the typical 4 areas where most of the work is done. So there is the data store where the data is stored, and there's a data pipeline built, which there is real-time pipeline and batch pipeline that's built to process the data into the data store. And then there's a traditional BI and visualization aspect, which basically looks at data historically and then reports on data, how things are, how things were in the, in the past year or past month or whatever, right? And then the final layer, which is I think the most interesting part of all this big data analytics is the analytics is where we are using it to predict certain cases, predict how certain events may occur in the future. So that's sort of the very high level view of the 4 layers.
So we start down here though, right? We start to build the data store.
Yeah.
Okay.
Yeah. We try to identify the data store, what kind of data store we want to use. So what I did was okay, each of these layers have various components. So I started breaking it down. So the data stores typically, what you think about big data stores are like Hadoop, NoSQL databases. There is MTP databases, which is like companies like Pivotal, which make really large scale, fast databases, which is on the same lines of Hadoop, which is meaning scaling out sort of technology. And then in terms of the data processing, we have the real time as well as the batch data processing. And the next layer is the BI and visualization. I talked about it. And then finally, in terms of the analytics layer, we have the analytics platform, we have the machine learning tools and techniques, and then finally we have statistical data mining techniques that we use around analytics.
And you have another similar slide like this one.
Yeah, now this actually goes in further into the actual tools that go into each of those components. So for example, the Hadoop, Hadoop was there from the beginning, and then Spark is coming. Spark Reside. It's a technology that is like probably 10 times faster or 100 times faster in terms of processing data in memory compared to Hadoop and MapReduce technology. And so that's one of the things that is really catching up lately. And there are the NoSQL data source. So some of the more popular ones are MongoDB, Cassandra, Pivotal, Amazon Web Services are example of the MPP databases. We have in terms of the real-time processing, we have Kafka, we have Spark Streaming, we have Elasticsearch, ELK, Elastic Logstash, Kibana Stack, and then we also have Storm pipeline or Storm based libraries that help with real-time processing. In terms of the batch, there is SQL. There are companies like ETL tools, Pentaho, Talent, etc. that we use for traditional BI ETL processing, and they're still used for batch processing. In terms of visualization, we have Tableau, Domo, and Click. These are some of the names. There are many tools in this area. Chart.io, Tableau, D3 are sort of real-time visualization tools, or I would say modern visualization tools. Domo and ClickView are more BI focused, I would say, where you can actually do analysis, where Chart.io or D3 are just visualizations and look at the patterns and trends between the data. And the top layer, the analytics layer, we have companies like Planter, Periscope Data. They are like core platforms for data sciences. In terms of the analytics, there is the IBM Watson, there's Skytree, which are machine learning platforms, and then the traditional statistical tools like SAS, MATLAB, and R. R's coming come along a long way in terms of it's a truly open source platform, and it has lot of power and features that almost SAS and MATLAB used to provide to people at a very high cost.
So that was a nice, easy view, because look what, I'm going to pass our little pop quiz. Look at that, everybody. Shrikesh was making it easy on us. Are these the current vendors in this space right now, Shrikesh?
Yeah, these are like about, this is kind of, so every year they come up with this this landscape image, and over the years it has changed. There are about 600 companies here that are operating within the big data analytics space, and it's really amazing how so many new startups are starting literally almost every day in different areas. And one of the things I wanted to highlight is in the next slide, Robin, which is yeah. So here it shows that earlier on when we looked at the landscape, a lot of the industries were operating in the infrastructure and applications area, but today, as you see, most of the companies are in the analytics area.
Hey, look at this one. I like this one a lot. We're really early. That's a good one for us. Okay, moving along. What's this one? Tell us about the architecture.
Yeah, this is sort of a typical architecture that you have when you're implementing big data, and I have left it at a very high level. There are different combinations you can have of this around this architecture. Typically, it's called the Lambda architecture. It means that data coming in from various sources, it is processed in real time, and there are real time decisions made. Also, the data is stored into processed and stored in into a Hadoop-like system where you can do historical analysis and you can look back on data for years and years. So that's like two different processing and two different use cases of data as it is processed through, and it's stored in different types of databases. And the examples that I used earlier about how the analysis is done, there's the BI versus the analytics. So different people using the data with different use cases.
Hey, I did see a question come through really quick. What does API mean? That came through on the chat. I like the chats on the top, guys, for those who have figured that out. Quickly, Shrikesh, what is API?
API is just an interface. Think about an interface between an application and the underlying technology. So an API is typically a way, or it's an interface that defines the rules of how we interact with the underlying application.
It's like the bridge, right, between applications.
It defines the rules and how you will exchange data between the application.
Thank you. Good question. Okay, moving on. Where to begin? Oh my gosh, where to begin? And we only have about 8 minutes. What do you think? Can you speed race through this?
Yes, I think I'll just see. So I was going to talk about identify where do we start. So I think the most important thing that anybody can do is making a business case, and I'll talk about how to go about making a business case, and then quickly breeze through some of the other sections.
Okay, and for those of you, we will also be here for you afterwards, and also make the slides available to you, because some of this content is very checklist worthy. So talk to us about making the business case.
So making the business case, I think one of the most important things that we can do today is to use data to influence decisions that we make. Instead of using, instead of going by hunch, or instead of going by, our thoughts driving decisions, I think if we use data to make the decisions, that's the power of big data analytics, and that's where the idea of business case comes in, which is what are the areas in the businesses that we can use data to solve a business problem, or we can use it for decision making purposes. So, and in terms of how we go about making the business case, I think we identify the business benefits. You identify an area where what the user's needs are, and the solutioning around it, and then quantify the value, right? So if we were to build this big data analytics platform, what is the value we're going to gain out of that, and and define it in terms of the ROI, define it in terms of hard dollars, what we're going to get, and that's the starting point of making the business case. And the things I have listed here is find areas where it will benefit the business the most. So the fraud example, where tons and tons of dollars were lost in the bank, in the financial industry. So that was the biggest area of focus for them. And one of the things that most of the people who are listening to this talk, they're thinking, oh, you know what, big data, it is so huge, it's probably not applicable to my business because we don't really have that volume of data. But although there are big data analytics started out with big data, and and the tools and technologies are built to handle big data, I think a lot of companies who don't have as much data can use the technology around analytics, the technology around how real-time data is processed. It doesn't have to be big, and then use it to solve business problems. The technology is, a lot of it is open source, a lot of it is just available at a low cost, and even companies that don't have a lot of data can actually use these technologies. Some of the examples I have here is.
I'll move on because I know we want to go quickly, but even like at Omnicon, we have found all kinds of ways to dig into our Salesforce data and pull that apart, and some of our recruiting things, like tools that we've had for years and years, where we just kind of filled in the blank or asked the question of the structured database. This has opened up my whole world of possibilities that we're playing with data in our data lab, which we'll be making available to you guys as well. Okay, so first thing was the business case.
So now you made the business case. So you say, okay, the next thing is, okay, what tools do we use, right? So there are different ways to go about it. I think the most important thing is to understand the technology landscape, and I think the IT people would do that, and identify the technology that fits the best in your company. There is no one vendor that has a solution across all the different layers that I was talking about. You will have to deal with different vendors to solve different problems, and that's just how vast it is. Typically, in terms of the data storage, you start with the basic Hadoop system, which companies like Cloudera, MapR, or Hortonworks, that's the elephants there. They are solution providers. They provide end-to-end solution. They come up with Hadoop versions that you can implement. It comes with management tools, and it's very easy to implement. There are benefits with using a Cloudera versus a MapR or a Hortonworks. I don't have the time to go into the details right now, but if there is no budget to go with companies like that, there is the other option, which is we can completely go open source, use the Apache software. It's free. You can just implement, install, and actually use it in production. At MGO, I'll tell you, everything that we used at MGO in my last company was all open source. we did not buy any of the solution vendor providers. It's not that, I mean, it's not the, I'm not going to say that's the right approach to go. I mean, it requires skill sets, and if the company has the skill sets, then that's one way to save a lot of money.
Yeah, I like that second bullet. Tools should be aligned with the employee skill sets. Let me change to the next slide. So you got your technology, and then you move on to your... So you got
your technology, and then, so now you want to think about, okay, how I'm going to process the data. So that comes back to the business problem that you're trying to solve. So if you have real-time needs for predicting some analytics in real time, then you need to go with the streaming option, or you could just process in batch and then predict. It is not going to be prediction real time, but it can still predict things that in non-real time mode. So the things to consider here, there are different options available in terms of what kind of real time processing you're doing, how fast you want the data to flow through, and all that considerations will go into the type of technology used. Some things that will help is, I would say, to use the right data formats. A lot of the time we use JSON end-to-end to process data through, and also use compression. And using compression really helps in terms of the processing time. And the final bullet there is, test your solution. And in terms of analytics, I talked about these companies. When you're doing analytics, start out with the analysis, start out with visualization, try to understand the interrelationships between the data, so that you can come up with, and this is in terms of machine learning, so that you can come up with the right feature set. Do the error analysis, make sure that you're finding the right balance between false positives and false negatives. And I can, these are all large areas to talk about, but sort of some of the the basic things that you would do in terms of analysis. I think I've mentioned that here, which is start out small and iterate and fine tune quickly. And then use the error analysis technique, so that your the algorithm you are using, you can understand that, okay, is this the right algorithm to be using for this kind of prediction. In terms of R and Python, there are things that have that people question, that can these technologies be used in production? Yes, they can be used in production, and we have used it. And finally, you have you thought about your analytics, and then you want to go ahead and actually build the system. The first thing you do is you go and buy the hardware. And the most common thing that you hear from people is, okay, the big data, you can buy commodity hardware and you can scale out. And I would although that is true, there is a big difference in terms of the hardware that you use. For example, if you use a 5600 RPM drive versus it's 7200 RPM drive or a 15K RPM drive, these all have much data. Or if you use SATA drives, it have different data throughput from 50, 60 megabytes per second to 200 megabytes per second. So that just shows you the skill. Almost you can get 3 times performance if you use the right hard drive. And same with the network bandwidth. Make sure you have the lot of these technologies, they totally depend on the underlying network backbone. So it's very important to have the right kind of networking.
What about this one?
Right, and this one is, it is oftentimes hard to buy all the hardware to do all this stuff on the premise yourself. So there are companies that provide end-to-end big data analytics solutions. So so companies like Amazon Web Services, Google, IBM, Microsoft, you can start small with these cloud providers. And the advantages is, it just helps you build and deploy faster, and you can scale out as you need. You can just grow your cluster, and many companies are doing that. And I think most of the startups are just going with one of these cloud providers, and that's how they grow.
That's cool. Yeah, it's a good way to go. And it's no walk in the park either. You still have to know what you're doing when you call to order these services. So, okay, that was a good checklist. Training and getting help. Talk to us about this one.
And this is the most important thing. I think out of all of this, the big data analytics is really a hard area. There is a lot of different pieces. If you don't have the expertise in-house, I would say go and ask other experts. There are so many blogs, there's so many community websites out there where you can get information. And I would say ask the experts when you don't have them in-house. And finally, when you are working on a big data project, I would say make sure your staff is trained and they understand these technology and understand how they all interact, all the different pieces interact with each other. And that's, I think, the most important thing that I wanted to highlight also in this slide.
Thank you. So we're going to open it up for Q&A in a second. We have about 1 or 2 minutes left. I just wanted to let you know that for attending today, we will be offering a 15% discount on our Big Data Fundamentals class, where we really dig into all the layers that Shrikesh went over. And we also play with Excel and let you practice consuming big amounts of data, even with Excel. We thought that would be fun to show you the power that you could have as your own data scientist. Yay, I love that comment. And also, if you want to talk more, we would love to offer a complimentary consultation. I know we went through it fast, but just on that checklist that Shrikesh went over, Omnicron also has our own big data lab. So if you want to do a little bit of a test drive on a business case and say, hey, Omnicron, let's practice, let's use your data lab so I could prove out my test case so that I could take it back to the CIO or the CEO and we could do it. So we'd love to help you with that. And I duplicated, I love that idea so much, I put it on the next bullet. So we definitely have a big data lab, and we are looking for business test cases. So bring your data here and we will put it together. Train your staff, we can help you with in-house training, and also we can help you with recruiting. And there's my contact information, and also you have our contact information from the attending. So now let me stop sharing my screen and I can see the chats. First of all, hey, let's give a big round of applause to Shrikesh. Thank you so much, Shrikesh. Yay!
Pleasure.
That just really scratched the surface for Shrikesh's knowledge. We also have our faculty, Regan Zogby, who is a training, and we're coming up with, in addition to Big Data Fundamentals, we're coming up with R and Python and some other great stuff. So let me look at some of these comments and questions. I am customer service supporting sales, and we use the business intelligence tool, which breaks down the metrics for use and reports, definitely. And I'm finding that a lot of BI tools, business intelligence tools, like SAS and Teradata, they are also opening themselves up to work with more unstructured data. I have an FYI here, big data analytics in the real estate industry helps to determine asset management, portfolio strategy decisions by observing population behavior. Interesting. And asset utilization based on badge access. Very, very good comment. Very nice. What I'll be doing is pulling through a lot of your comments, and we will make an FAQ for you. so that you can see everybody's comments, and then if there were some things that we didn't answer, then Shrikesh can also answer them on the FAQ. And we'll also send you that lovely infographic and the copy of the recording. Any other questions? But I have a lot of chats to weed through here. So on that note, I just want to then thank you very much. We are basically, depending on which clock I look at, it's either 8:59 or 9:03. So I'm going to call it even and say that we're ending on time. So thank you very much, and talk to you guys after the webinar and get your feedback. Talk to you later. Bye-bye. I'm going to turn off the recording.